In this video, we'll take a look at an application problem from the finance world that evolves into a quadratic equation. Here we have the formula for compound interest, where A stands for the value of the account, P is the principal or the initial amount invested, T is time in years, and R is the interest rate. So in this example, they're asking us to determine the value of R if P, the principal, is $2,000, the ending amount is $2,880, and the time is 2 years. Replacing those variables with the value in our compound interest formula, we have the following equation. Because we eventually would have the variable to the second power, if we multiplied this out, we would definitely have a quadratic equation. To simplify this, however, we can divide both sides by 2,000, which leaves us with the binomial square. We can now use the principle of square roots and take the square root of both sides. Normally, when we take the square root, we would provide the positive and the negative solution of the radicals. However, since we're talking about an interest rate and this being compounding, it would be a positive number, so we're going to reject or ignore the negative solution. The simplification here resulted from the square root of 36 is 6 over the denominator square root of 25, which is 5. And on the right side, anytime you take the square root of a quantity squared, you end up with that quantity. Solving then for R, we'll subtract 1 from both sides, which leaves us with R is equal to 1/5. In a decimal form, that would be 0.2, and in terms of a percent, we move the decimal place 2 to the right, and so the interest rate that resulted in this kind of growth, given there was $2,000 deposited initially over a course of 2 years, is an interest rate of 20%.